Hello, welcome to Curious Lorenzo, podcast where I research in real time topics that I'm curious about. So today I wanted to know more about solar panels. There is a lot to the science about solar panels. The idea of using more solar panels and green energy is really important to, I think, the environment and Earth and reducing carbon emissions. Like you've heard all of the hot terms, and there's also some pushback on using more solar panels and solar energy. So I wanted to know more about what solar panels are and how solar works. So that's what I'm going to research today: solar panels. Also, I was, I haven't recorded a podcast in a while. I've been busy starting my job, adapting to a new place. I moved from Albuquerque to Portland, and there's a lot to adapt to, a lot to adjust to. My kids are doing online school, and I haven't recorded in a while, but I was just thinking about that this morning and how I wanted to maintain my kind of curiosity. It's in the name, Curious Lorenzo. Maintain my curiosity and to learn something new, because I've been learning a lot about my new job, and I've been learning a lot about Portland, and I've been learning a lot about my community and how people are different here. But I haven't really researched anything that interests me or fascinates me. So I want to know more about solar panels. And that's why I'm doing this right now. But there was a quote that I was thinking about this morning as I was sort of just throwing around the idea of recording this right now. And I knew a rough idea of what the quote was. The quote, when I looked it up, is the more you know you don't know. And according to the internet, Goodreads is what came up. This website called Goodreads. It's a quote by Aristotle. But I guess there's a similar quote from Albert Einstein that says, the more I learn, the more I realize how much I don't know. So two quotes that kind of are saying the same thing. And I like these quotes because, as you start to research something, as you start to educate yourself on a topic, you're uncovering all of this new information, and you can kind of just keep going on and on and on. And knowledge is infinite, and it's really, I think knowledge is a very beautiful thing. Like just to understand how something operates, how something works. And you can go on about the philosophy of knowledge and truth. And I think the more knowledge we know, the more educated we are, the more understanding we can have, the more empathy we can give to other people. And I don't know, I don't really have to get political or anything, but the inauguration of Joe Biden, that was his main idea, his main speech, is unity and getting to know each other. And he had a quote, or he said something about, Joe Biden said something about empathy. I don't think he used the word empathy, but he said something about how my mom told me to spend a little bit of time in somebody else's shoes, even just for a minute. And I like that. I like that message. The more you educate yourself, the more knowledge you gain about other people or about just how something works, the more informed decision you can make, and your entire existence can be just informed. I like that. Being informed, I think, is better than just making assumptions and living in fear. And I think you're more likely to follow what other people are doing if you don't have the information, if you don't have the truth. You see other people doing something that might not be true or might not be right, and you go with that instead of doing the work and researching it for yourself. So that's kind of, I just wanted to mention that. But yeah, so I'll go ahead and get started. Let's get into this. So what do I know about solar panels? So, basically what I understand about solar panels is they are these black. They're usually black, and that makes sense because black absorbs the most amount of light from the spectrum. They absorb sunlight, solar energy, photons from the sun, and I guess it could be any photons. everybody's done that trick with the, depending on how old you are, if you remember those old blue Texas Instrument calculators that they gave to you in like sixth grade math, had a little solar panel, and you could use a flashlight to place on that little solar panel and give it enough energy to work. Or you could cover the little solar panel, and then the LCD little display would start to fade. So that was actually, I think that's my first experience with solar power, was those little solar panels on those little blue Texas Instrument calculators. And I remember, and I was probably fifth, sixth grade when they introduced those to our classrooms. I remember just being blown away that, no, this doesn't need any sort of battery to operate. I mean, maybe it does. Maybe there's some sort of battery inside there that gets charged and holds some electricity and then distributes it as it goes. I'm not sure exactly the technology, but you don't need to. The main source of power for the calculator is not a battery. It's the energy from photons that are hitting that little panel and converting it into electricity to, power the device. So I was just blown away and so fascinated in how this works. And I remember even now, just like these memories are coming back to me, thinking like, there's so much potential we can use with these. Like, why can't we power my entire school with something like this? I mean, I was asking the questions as a kid, but I didn't know. I didn't understand how that worked. I know a little calculator doesn't take that much energy. A school would take a lot of energy. I know that now. But what sort of potential, what sort of power does this technology have? So anyways, yeah, that's my first introduction to solar panels and solar power. And what else do I know? So there are these little black squares. They're typically square, and you place them in sunlight. The sunlight hits the panel, and somehow in this process, the energy from the sun, these photons, are converted into electrical energy, electricity, somehow. I think that's what I'm most curious about, is how is a photon, which is energy, little packets of energy, how is a photon, which is also a wave and a particle, right? So that's some physics that's way above me. How is that photon that took that, 92 million mile journey from the sun to the solar panel, how is that converted into electricity? I think that's the biggest thing I want to find out. And I also want to find out where is this going? Where can this technology go? Where are we now? There's a lot of pushback from people saying that solar energy is a wasted investment. We need to use clean fossil fuels, which I've heard that term thrown around. Oh, that natural gas is clean, or clean coal, or clean oil, like that. That doesn't make sense to me, because no matter what if you're burning something, the byproduct of that is going to be carbon dioxide and a lot of other gases and chemicals that you're throwing up into the atmosphere. I think the solution is not going to be any sort of quote unquote clean gases that you're burning, or clean, any clean fossil fuels. I don't think there's such thing as a clean fossil fuel. I think it's all. I mean, I don't know what the definition of clean is going to be, but no matter what you burn, there's a chemical reaction that takes place where you're throwing some other gas in the atmosphere, which is going to be, not good. But solar energy seems like a really good solution to me. Even though there's a lot of pushback from a lot of people, I think it sounds like a great idea. I know the downside is you have to use a lot of solar panels, and that could harm the flora and the fauna of that area, right? So even if it's a desert, people think, desert doesn't have a lot of life. Desert has more life than you would think coming from a desert. Cactuses, they need that sunlight to survive. Desert grasses, desert plants need sunlight to survive. And there's a lot of animals that are depending on those grasses and cactus and everything else. That's their home. So yeah, I get it. Like solar panels are going to disrupt an ecosystem for sure. But so does building a house, right? So does building a city. So does building a town. How much of an impact does it have if you put a solar, a solar farm somewhere? How much of an impact is that going to have versus like if you're building a town or if you're building an interstate highway or a railroad or whatever it is that humans do? Maybe solar panels are best to be placed on the sides of giant buildings that are absorbing a lot of heat as it is, or on the roofs of, I've seen this on the roofs of parking structures. Like you have a parking lot, and I've seen this happen in Albuquerque, and I think it's a really good idea. You have all these parking lots, and in Albuquerque, the sun, it seems like it never goes away. It's always sunny. And one of the things that we complained a lot about in Albuquerque is when you would get into your car, it would be super hot. You'd open the doors and like this, it would be like an oven, and this super hot, dry air would just come out of your car and blast you in the face, and it's just like so hot. And then you get in and buckle your seatbelt, and the buckle for the seatbelt is hot, and if you touch it, it'll like burn you. It burns. It gets that hot inside the cars. But I saw this happen at the zoo, and I think a couple of other places in Albuquerque where there was they would put up these shelters, these car shelters, which is beneficial for maybe more than two reasons. But the two reasons that I noticed right away was it allows for shade of your car, so that the cars don't get super heated as you're like enjoying the zoo. And you come back, you have kind of a little bit of a cooler car, which is nice. And on top of that, there's solar panels installed on top of these car shelters that is collecting all of that solar energy and converting that into electricity and used for something. I don't know what it's used for. Maybe they put it back into the grid. Maybe they use it to power the like the parking lot lights, or they use it for something, right? Something that's needed. They need electricity for. So I thought that was a really great idea for a city like Albuquerque. Or putting a solar panel on top of your home. There's already, your roof is already absorbing a lot of energy. Why not put a solar panel there already? Because you're not using additional land to put up a solar panel in that case. So, yeah, there's a lot of solutions people are thinking of. There might be some problems. I'm wondering how efficient it is. Like, why are people pushing back on it? Like, it's a lot. So I wanted to know, how does it work? And I'm typing this down so I don't forget. How does it work? And I also wanted to know, what did I want to know? How does see, this is how my mind works. I get going, and then I forget where I was. So I want to know, how does it work? And I wanted to know like how efficient it is, how useful it is. Where are we with it? I'll just start from there. So let me go ahead and let's Google this. How do solar panels work? All right. So this time I'm not going to use Wikipedia, because the first article that comes up is from a website called select.com. And this looks, I don't know what this website is, but it has some information, and I'll just go with that. Basic steps for solar energy generation and transmission. Step number 1, sunlight hits the solar panels and creates an electric field. Okay, so the photons hit the solar panels and it creates an electric field. Okay, step 2. The electricity generated flows to the edge of the panel. So the electricity that it has flows to the edge of a panel into a conductive wire. The conductive wire brings the electricity to the inverter, where it is transferred from DC electricity to AC, which is used to power buildings. Step 4. Another wire transports AC electricity from the inverter to the electric panel on the property, also called a breaker box, which distributes electricity throughout the building. Step 5. Any electricity not needed upon generation flows through the utility meter and into the utility electrical grid. As electricity flows through the meter, it causes the meter to run backwards, crediting your property for excess generation. And I've known that. I've seen people in New Mexico, like in the East Mountains where there's a lot of wind. East Mountains is like, this is the area east of the Sandia Mountains. It's super windy a lot of the times, and what people would do is they would put up like these homemade like windmills, and they would connect it to their power grid, and their electricity meter would run backwards, therefore crediting them. So if you put enough energy back into the grid, you can even get a credit if you have a like if you have a surplus of electricity that you're generating. So which is pretty cool. All right, so these are the basic steps, but I think the most important piece I was trying to understand was sunlight hits the solar panels and creates an electric field. So what does that look like? I am going to dig a little bit deeper into this. So let's go ahead and do solar energy, and I'm going to do Wikipedia. It's my go-to. Solar energy, Wikipedia. So let's read this first little section here. The intro usually is packed with the most kind of 30,000 foot summary of what I want to understand. All right, so Wikipedia article. Solar energy is radiant light and heat from the sun that is harnessed using a range of ever-evolving technologies such as solar heating, photovoltaics, I guess that's how you say it, solar thermal energy, and solar architecture, molten salt power plants, and artificial photosynthesis. It is an essential source of renewable energy, and its technologies are broadly characterized as either passive solar or active solar, depending on how they capture and distribute solar energy or convert it into solar power. Active solar techniques include the use of this is a hard word for me, photovoltaic systems, concentrated solar power, and solar water heating to harness the energy. Okay. Passive solar techniques include orienting a building to the sun, selecting materials with favorable thermal mass or light dispersing properties, and designing spaces that naturally circulate air. The large magnitude of solar energy available makes it a highly appealing source of electricity. The United Nations, again, it goes on and on about where we are. All right, so in the first sentence, solar energy is radiant light and heating from the sun and is harnessed using a range of ever-evolving techniques and technologies. So, and I should have known this, there's not just one way to harness the energy of the sun. Solar thermal energy, I can kind of guess an idea. We had when I was in college, I lived in this little mother-in-law edition house in the back of somebody's land, and they had a water heater, but they also had, to heat their water, they had these pipes that were brought up above the house into this like solar panel looking thing. And these pipes would be coiled in like a, back and forth on top of the roof, and the water would heat from there, and then it was put into the water system, into the water, pipes for the house, and that's where most of the hot water came. And I remember living there. The hot water was really, really hot, and so I guess that would be like a solar thermal energy, maybe not. I'm probably wrong. But that's okay. I'm used to it. So there's a lot of different ways, but let's see. And the artificial photosynthesis, that seems really interesting to me too. I taught biology for a little bit, and photosynthesis is one of those processes that really blew my mind. And plants have evolved this ability, and they've perfected it, and they are so good at turning photons, light energy packets, into sugar. And it's a super complex process, and there's a lot that goes into it, and there's a chemical formula that is attached to it, and let's see if I can remember it. Nope, not going to remember it. But there's a formula attached to it, a chemical formula, a process that is attached to it. And when I was teaching this to my kids, I thought this is just one of the most incredible things, that plants can do this. Plants have evolved a way to harness the energy of the sun. And here we are, humans, trying to be even just a little bit efficient. And plants are really good at just taking that taking that energy from the sun and turning it into food. And in fact, if it wasn't for that process, none of us would be here. That's where all of our food starts, which I remember just teaching that to my kids in high school biology and just getting so excited about that. They probably thought I was weird. I am weird, I guess. But it's just mind-blowing. All right, so artificial photosynthesis. What's the other one? Photovoltaics. I'm probably saying that wrong, but there's a sub Wikipedia article. Let's use my computer to pronounce this.
Photovoltaics.
Photovoltaics. All right, so I think this is the process that I'm really wondering about. The solar panels you've seen all over the place. Photovoltaics is the conversion of light into electricity using semiconducting materials that exhibit the photovoltaic effect. Okay, what is the photovoltaic effect? Is the generation of voltage and electric current in a material upon exposure to light. It is a physical and chemical phenomenon. So there's a physical and chemical phenomenon that happens in this material that converts light into an electric current. Okay, we're getting somewhere. A phenomenon studied in physics, photochemistry, and electrochemistry. Oh, electrochemistry, that's interesting. The photovoltaic effect is commercially utilized for electricity generation as photosensors. Okay, what is a photosensor? Photodetectors, also called photosensors, are sensors of light or other electromagnetic radiation. A photodetector has a P to N junction that converts light photons into current. The observed photons make electron-hole pairs in the depleted region. Okay, so I think this is where we get into the nitty-gritty of this. So let's see. The absorbed photons make electron-hole pairs in the depletion region. So there's a lot of this can get really knocked the table. There's a lot of information here. Photodiodes and the phototransistors are a few examples of photodetectors. Solar cells convert some of the light energy absorbed into electrical energy. All right. So I don't know how deep I want to get into this. I think this is where it gets really into the science of things. But essentially, you have photodetectors and photosensors that convert a light photon into current. And I guess the basic gist of how that happens is the absorbed photons make electron-hole pairs. So let me find out what that is. In the solid-state physics of semiconductors, carrier generation and carrier recombination are processes by which mobile charge carriers are created and eliminated. Carrier generation and recombination processes are fundamental to the operation of many optoelectronic. And it cut off right there, so I didn't read the rest. But there's a lot there. A photodetector has a P to N junction. A P to N junction is a boundary or interface between two types of semiconductor materials, P-type and N-type, inside a single crystal or semiconductor. The P positive side contains an excess of holes, while the N negative side contains an excess of electrons. Okay. So the absorbed photons make electron hole pairs. All right. This is going to be some homework for me. I'm going to read this later on, but that is kind of just scraping the surface of, I mean, not even scraping the surface, but like getting a simple understanding of essentially photons are converted into electricity in a photodetector or a photosensor because of science, because of some science that is so uh, so complex for me right now. Just kind of talking about it over a Wikipedia article. I'm sure people go to lots and lots of years of school to understand how this works, but it's really fascinating. All I need to know is it works, it happens, it's a phenomenon that is there, and we can harness that and essentially just turn photons into electrons. So yeah, good stuff. All right, so I'm going to take a break, and I'll be right back. All right, I am back. And so far I've kind of covered my knowledge of what solar panels are, how solar energy works. And I've also gone into, the basics of what a solar cell is, which I didn't really touch too much on because it is very complex physics that honestly, I have no idea how I would. I mean, I can't just read it and understand it on a podcast. I'm going to have to actually look into that more if I want to learn more about it. Which also touches back on that quote that I read at the beginning of this episode. The more you know you don't know. So basically, you can just keep digging and digging and digging, and even the most expert. The most well-versed experts in solar energy still don't know everything there is to know about solar energy. They're researching, they're finding out new things, and I think they might have gotten to that place where they're uncharted territory, and everything that they sort of discover is new, and that would be an interesting place to be, I think. And those are the people that, like Nikola Tesla and Albert Einstein and all these other really renowned scientists who have been on the edge of discovery. That's where they are in their knowledge, I think, is they've been digging and digging and digging. Now they've gotten to a place where everything they discover is new, and that's new to, it's new to our human as a collective knowledge. Like, that's new to everybody. And that would be a wonderful place to be. That's just something else. But I'm not there. I am definitely not there, and I don't know a lot about what's going on here, so I'm going to research myself a little bit more about how the actual cell works, and I kind of just digged in briefly about the photodetector and the photosensor, and it's some material basically that can convert photons into electricity, and there's phenomenons called electron hole pairs, depletion regions, photodiodes, all this other technology that's really cool. That I'm sure there's a few diagrams somewhere around that can explain those better, but I don't know what those are. So, what does solar mean for us? Because we know that fossil fuels being burned is not a good thing. Earth on Earth, humans are pumping in lots and lots and lots of waste materials into the air, into the atmosphere. And what's happening is those waste materials are what's called greenhouse gases. A greenhouse gas is just like it sounds. It's a gas that is insulating. So it allows any heat that is radiated onto Earth from the sun stays where it is. It stays put on the Earth. It doesn't radiate back out into space because of these gases. Excuse me. Some of those gases, some greenhouse gases are good. We don't want to be like the moon that doesn't have an atmosphere, where the sun's energy hits the surface of the moon, and it all basically bounces off and goes back into the atmosphere. That would not be good. We also don't want too much. An example of too much would be, I think, Venus. In fact, let me verify that. It's one of the planets that's closest to the sun, other than that's Venus or Mercury. Venus greenhouse gases. Just Googling real quick. Venus is similar to Earth in terms of size and mass, but its surface temperature is about 460 degrees Celsius. This is hot enough to melt lead. The Venetian atmosphere is mainly made up of carbon dioxide, which is a greenhouse gas. So yeah, Venus has a lot of carbon dioxide, has a lot of that greenhouse gas, and basically any heat that goes to Venus, a lot of that is just trapped in their atmosphere, and it makes it super, super, super hot. So we don't want that on Earth. We don't want that carbon dioxide to go into the atmosphere, but we, as humans, have been burning for 100 years now a lot of greenhouse gases, and it's starting to have an effect on our planet. Weather changes are taking place. Climate patterns are shifting and adjusting. We're a little bit hotter. Polar ice caps are melting. Animals are losing habitat. There's a lot that's going on as a result of these greenhouse gases. So we want to have renewable energy that doesn't have like a byproduct that's a waste that you put into the air. I mean, I've kind of just off the top of my head listed the negative attributes of solar. If we have solar farms, you're covering a lot of ground. You're covering a lot of ground, and you're taking away habitat from animals, which is not so great. But I'm typing right now solar plants because there's different types of solar plants. I saw in California, close to Las Vegas, where there's a lot of solar available. The sun is always out. It doesn't really rain that much in the Nevada desert or Nevada. It's close to Las Vegas, where you, as soon as you drive south, whatever interstate that is, from Las Vegas into California, there are these two huge solar plants right on the California border. And I'm typing right here, solar plants by Las Vegas, Nevada, and they're not taking up a lot of acreage, but what happens is, just from observing this, is the solar energy hits these mirrors, and that light is then reflected and focused on one focal point, one area on the top of this tower. And as you're driving south, you can see it's bright. It was the middle of the day. It's a bright summer, sunny day, and looking on the horizon, I see this light, and it's the brightest light I've seen in the middle of the day, ever. So I'm wondering, what is that? I didn't know. I had no clue what this was. But it's a solar plant, and just from a simple search, I think this is what it is. It's a Ivanpah solar energy generating system. It's in the Mojave Desert. It is located on the base of Clark Mountain in California, across the state line from Primm, Nevada. The plant has a gross capacity of 392 megawatts. It deploys 173,500 heliostats. Which a heliostat is a device that includes a mirror, usually a plane mirror, which turns so as to keep the reflecting sunlight towards a predetermined target. So yeah, it has these mirrors that are moving as the sun moves. And I just learned what a heliostat is. That's cool. Each with two mirrors focusing solar energy on boilers located on 459-foot tall solar power towers. The first unit of the system was connected to the electrical grid in September 2013 for an initial synchronization test. The facility formally opened February 13, 2014. In 2014, it was the world's largest solar. Let me slow down. It was the world's largest solar thermal power station. It was $2.2 billion. Facility was developed by Bright Source Energy and Bechtel. The largest investor was NRG Energy. So it's the letter NRG Energy. It's interesting. I guess NRG is an American energy company based in New Jersey and Houston. That doesn't matter. Which contributed $300 million. Google contributed $168 million. The United States government provided $1.6 billion loan to guarantee the plant to be built on public land. In 2010, the project was scaled back from its original 440 megawatts, designed to avoid disturbing the habitat of the desert tortoise. Interesting. So there's some pushback on some of these methods to generate energy because it can disrupt local ecosystems. So that's one solar plant that I guess it's not a lot of acreage like solar plants that I've seen in New Mexico. There's a solar plant that was built close to my house where I grew up in Moriarty. Let me see here. So that one is the Affordable Solar constructs the largest facility on PNM system, and it's a 50 megawatt solar project. I'm looking at this website from affordablesolar.com, who has it. Albuquerque-based Affordable Solar announces the completion of the Britain Solar Energy Center, owned by NMRD, a subsidiary of PNM, which is the electric company in New Mexico. The construction located in Moriarty in Torrance County began in March of 2019. It took 8 months to complete. It's 520 acres. Yeah, there you go. Sitting on 520 acres of land, Britain's Solar Energy Center captures New Mexico's sunshine with over 180 solar panels. The facility would generate enough energy to power 25,000 New Mexican homes every year. So that's a good amount. 25,000 New Mexico homes. So that's, it's something. It's not like, so that's how many megawatts did they say this was? Let's see, subsidiary, blah, 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 50 megawatts. And this Ivampa solar energy facility was scaled back from its original 440 megawatts. This is just, this one is just, I lost the number again, 50 versus 450. So that's a big difference. You can do the math, how many more homes. So if 50 megawatts powers 2,500 homes, 450 is going to be much more. There's different solar facilities. This one is a concentrated solar thermal plant. That's the one in the Mojave Desert. And the one in Moriarty is just, I don't know if it says what type it was, but it's just solar panels that are sprawled out in 520 acres of land. The Ivampa one, I don't know if it's that many acres. Let me see if I can find it. Acres, 3,500 acres versus 520 acres. So yeah, I guess it does have a lot of acreage. But from what I observed, just passing by on Interstate 15 in California, was that it didn't seem like it was that much sprawl. It just seemed like these mirrors were in this circular pattern, focusing this light onto this boiler on top of this tower. Didn't seem like it was carrying that much. Didn't seem like it was taking up that much space. So back to my original question, which was the efficiency. So efficiency, is solar energy efficient? I'm just typing in Google. And I like that Google puts out other questions that people are asking. Is solar energy the most efficient? These are other questions I guess people are asking. How efficient is solar energy compared to others? That's kind of what I want to know too. Why solar energy is not efficient? So somebody asked the question already with an idea that it wasn't efficient. And then the other one, can solar panels be 100% efficient? And I already know the answer to that. The answer is no. No energy, as far as I know. I guess I don't know, but I have an idea that I don't think anything could be 100% efficient. Even like coal energy, which you're burning coal, you're losing. You can't be 100% efficient on something. You're losing energy in some way. Inside the system, energy is going to be lost somehow. Whether it be heat radiating off the boiler where you're burning the coal or whatever it is, you can't be 100% efficient. So yeah, that's that. But let's see, how efficient is solar energy compared to others? So here's this website. Open the link in the new tab. It is from greenmatch.co.uk. It says, while solar panel energy is generally around 15 to 20%, efficiency is generally 15 to 20%. So I'm guessing of the 100% of the energy collected, 15 to 20% of that is usable. Solar cell efficiency can reach 42% in some cases. However, unless otherwise stated, the performance of solar cells is measured under laboratory conditions. Okay, that makes sense. You have laboratory conditions where you're maybe blasting a solar panel with light, and you can measure the efficiency that way. But you can't predict the weather. I mean, I'm in Oregon right now, and I see solar panels on houses here. But the only time the sun is consistently out is in the summer months. So June, July, I think a little bit of August. Right now, this time of year, it's almost never sunny. Today, the sun is out. So after I record this, I'm probably going to go outside and soak up the sun a bit. But in winter months, I don't think a solar panel is going to be super efficient. You're going to get a little bit of sunlight. Sunlight that's peeking through the clouds, like just some of that energy. Some of those photons are coming through the clouds, but a lot of that energy is being absorbed by the clouds above us. So that makes sense that the efficiency has to be calculated, I guess, in your region, how cloudy it is, how much direct sunlight you are, like where are you longitudinally? Is that a word? Longitude wise, like if you're on the equator, you're probably getting a more direct hit from the sunlight versus like if you're in North Dakota, you're probably not getting a super direct sunlight, or even like Alaska in the winter months. So it all depends, I guess. But from what it sounds like is 15 to 22% is a good number. Let me see if there's any other sources here. So that's from greenmatch.co.uk. We also have solar panel efficiency from solarbyempire.com. These look like they're from company websites. Let's see. There's a Forbes article. I guess I can go to that. I guess, if you have a solar panel company, you want to kind of spin it in a way. But this is a 3-year-old article. It said, I don't know if I want to go with that old of an article, because as the Wikipedia article said, the technology is rapidly evolving. So let's see here. Here's one from Consumer Affairs, solar energy versus fossil fuels. So this one is saying that solar energy has an efficiency of 15 to 22%, which that last article said. So I can kind of see that this is a bit more reliable. And fossil fuels are between 20 to 40% efficient. The problem with fossil fuels is that it has CO2 emissions. Solar energy does not, and that's what this article is showing. And solar energy has long-term availability. So basically, the sun's not going away for a while. We're hoping to keep it around, but fossil fuels, we can deplete that source. There's going to be an end to how many fossil fuels we can suck out of the ground, unless we're going to start to use methods like fracking in Oklahoma and Texas, and I don't know if they do it in New Mexico, probably southeastern New Mexico, where there's a lot of natural gas and oil. We are going to come to the end of our fossil fuels. Sunlight is, like I said, going to be here for a while. We're hoping. So yeah, there's pluses and minuses. All right. So I think I've gone as deep as I want to get into this topic. I want to know more about the actual process. I think I'm going to take some time to do that. Learn more about the photoreceptors and the actual process of how a photon is converted into an electron. That is interesting to me, but that's gonna require me to sit down and actually focus on maybe looking at some diagrams. I do really well with scientific diagrams, versus just reading whatever science journal wrote about how the process works. But I'm gonna sit down and try to learn more about that. But from what it sounds like is that solar is a good, is a really good, like, not a main source, not the main source of electricity, but it could be a really great supplemental source. And I see a lot of opportunities where we can put solar panels. I know Tesla has cars that like the new truck, the Tesla truck has a solar panel on the roof. If you're going to be going out in long distances, you want to have energy, especially if there's not a charging station close by. So, putting it on vehicles, putting solar panels on cars, on I could see big factories. I remember driving on Montano in Albuquerque, from Montano and I-25, driving west. I think it was the Costco building or one of those big buildings on the north side of Montano have solar panels all throughout the roof of their building. I think that's brilliant, because that is just soaking up energy. There's so much energy that's just being lost. I think that if we start covering things, especially if we don't need to look at it, if it's not bothering anything, it's not harming any animals or plants or anything like that, put solar panels there. I think that's such a great idea. One day when I'm a homeowner, if I'm a homeowner ever, right now I'm not, but I'm striving to get to that point. If I'm ever a homeowner, I'm going to seriously consider that investment. I've talked to one person who I used to work with at the high school I worked at. He was talking about the investment he made into solar panels, and it is a big investment, but there's subsidies you can get, and after a certain amount of time, like the actual savings cost that you get from generating the electricity from your home gets paid off, and then if it's efficient enough, you can actually start making some money from the energy that you're generating. So instead of writing a check to your utility company, they're writing you a check, and I think that's great. I don't know if I don't know how that works actually. I don't know if there's an agreement with the company that if you put an X amount of megawatts back into the grid, if they'll cut you a check. I think that'd be really cool. But I imagine because they're a business, they don't want everybody generating a surplus of electricity. I don't know how that works, but it's interesting to me. It's that you can put electricity back into the grid if you're efficient enough and if you're conserving enough. And ultimately it comes down to taking care of this planet that we have. I think that's vitally important. Maybe not super vitally important for me or for people my age. I think that we're going to start seeing effects of, we are already seeing effects of climate change right now, but I could probably live a long life and not be super affected by climate change, but I have kids, and they might see those effects being more drastic. And then their kids, so my grandkids, if I ever have grandkids, are going to see those effects even more drastic. So it's all about just sort of thinking into the future and taking care of the biggest resource that we have, which is our planet. We have to have this planet. We have to live here. And to come up with solutions to preserve it, I think, are super important. And honestly, a big responsibility for everybody. And I've gotten complacent a lot of times. I use a gas-burning vehicle. It's not efficient. My wife has a hybrid, so it's a little bit more efficient. And it's good for us, too, because we don't have to spend so much money on gas. And the car can get us a lot of different places for pretty cheaply. But my vehicle is not a hybrid. It's a V6 Toyota engine, and it uses a lot of gas. I'm probably at about 18 miles per gallon, so I'm not exempt. The house that we live in has super inefficient little space heaters in each room, and I felt the pain of that this last month when I got my electric bill and it was close to $300. So I have an incentive to use less. Because I can't do a $300 bill every month. That is just not something that I can sustain. And also, if I think about the bigger picture, it's not good because however the electricity is generated in my area, I think in Oregon, I don't know what the percentages are in Oregon, but I imagine some of that comes from a coal burning power plant. maybe more of it in Oregon comes from renewable energy versus New Mexico. New Mexico gets a lot of their energy most of their energy from the Four Corners power plant, which is coal. But either way, it's good to be responsible. It is my responsibility to make sure that this planet is better off. I mean, much less not harmed, because it's not. We can't just go to a new planet. We don't have even the technology to do that. And also, Earth is pretty special, I think. I like our planet, and I think it's a good idea to make responsible choices. Well, I want to keep the luxuries of having electricity. I like having my lights on. I like heat. I like being able to record this podcast. I like to use my computer. All of that is really great. But if I don't have a planet to enjoy it, then, it's all for loss, right? So yeah. Good stuff. Solar panels. I've learned a little bit. I've also, again, found out that the more I learn, or the more I know I don't know, Aristotle. And the more I learn, the more I realize how much I don't know, Albert Einstein. So, good times. Hope you enjoyed this episode, and I will talk to you on the next one.